What if space is not empty, not physical, not even real in the way we imagine it, but instead, a vast ocean of information? Welcome to Information World. For centuries, humans have imagined space as a giant container. A dark stage where planets move, stars burn, and galaxies collide. We picture space as something solid in concept, 3 dimensions stretching endlessly in every direction. But modern physics, computer science, and philosophy are quietly suggesting something far more radical. What if space itself is not a thing, but a description? What if space is nothing more than organized information? To understand this idea, we need to let go of intuition. Because intuition evolved to throw spears and build fires, not to understand the fabric of reality. When we look deeply past atoms, past particles, past energy, we begin to see patterns. And patterns are information. At the most fundamental level, everything we know about the universe comes to us as data. Light reaching our eyes. Signals detected by instruments. Numbers written into equations. Even distance itself is never directly experienced, it is inferred from relationships. From time delays. From interactions. From comparisons. Space, strangely enough, is always defined by information about something else. Physics already hints at this. In quantum mechanics, particles don't have definite positions until they are measured. Before measurement, they exist as probabilities, mathematical descriptions. A particle is not here or there in the classical sense. It exists as information about where it might be. Position emerges only when information is exchanged. This leads to an uncomfortable question. If position requires information to exist, then what is space without information? Einstein changed our understanding of space forever. He showed that space and time are not rigid backgrounds. They bend, stretch, and respond to mass and energy. Space-time is dynamic, not passive. But even Einstein's space-time is still something that curves. Yet modern theories go further. They suggest space-time itself might emerge from deeper, more abstract structures. In recent decades, physicists have discovered something shocking. The amount of information inside a region of space does not scale with its volume but with its surface area. This is known as the holographic principle. According to this idea, all the information contained within a 3-dimensional region of space can be fully described by data stored on its 2-dimensional boundary. Think about how strange that is. A 3D universe behaving like a hologram. Depth emerging from flat information. Reality behaving like a compressed file. If this principle is correct, and many physicists believe it is, then space is not fundamental. Information is. This idea gains strength when we look at black holes. Black holes were once thought to destroy information. Anything that fell in was lost forever. But this created a massive problem, because the laws of physics insist that information cannot be destroyed. After decades of debate, the conclusion was astonishing: information is preserved, encoded on the surface of the black hole, not inside it. The event horizon behaves like a storage device. A cosmic hard drive. Every particle, every interaction, every bit of matter that falls in leaves an informational imprint on the surface. If information defines what happens inside a black hole, then information may define space itself. Now let's go deeper. In quantum field theory, empty space is not empty at all. It seethes with fluctuations. Virtual particles appear and disappear constantly. But these fluctuations are not things popping in and out of existence in space. They are changes in informational states of underlying fields. Fields themselves are not objects sitting in space. They are mathematical structures that define possible interactions. Space becomes the way these fields relate to each other. Distance becomes a measure of correlation. 2 points are close not because of meters, but because information flows easily between them. This leads to a powerful idea: space may be a network. Imagine reality as a vast web of informational nodes. Each node holds data. Connections between nodes represent relationships. Strong connections feel close. Weak connections feel far. What we perceive as spatial distance is actually informational distance. This idea appears in approaches like loop quantum gravity and tensor network models. In these frameworks, space is built from discrete informational units. There is no smooth background. No continuous fabric. Just relationships. If enough relationships exist in a certain pattern, space emerges like an image appearing when enough pixels are arranged correctly. This also explains why space has a minimum scale. At the Planck length, the concept of distance breaks down. Below that scale, where stops making sense. Because there is no finer informational structure to define position. Now think about this carefully. If space is information, then motion is not movement through a container. It is a change in informational state. Objects don't travel through space, they update their relationships with everything else. This reframes gravity entirely. Some modern theories suggest gravity is not a fundamental force. It is an emergent phenomenon. An entropic effect. Objects move not because space pulls them, but because systems naturally evolve toward states of higher informational probability. Massive objects distort the informational structure around them. Other objects follow the most efficient informational paths. We interpret this as curved space. Even time begins to look suspicious. If space is information, time may be the rate at which information updates. The universe computing itself, step by step. Not running in time, but generating time as a byproduct of change. This connects deeply with computation. Some physicists have proposed that the universe is a quantum computer. Not metaphorically but literally. Every interaction is a computation. Every particle interaction processes information. In this view, the laws of physics are not commands imposed on reality. They are rules of information processing. Constraints on how data can transform. This also explains why mathematics describes the universe so well. Mathematics is the language of information. If reality is fundamentally informational, then math is not a coincidence, it is the source code. Now let's bring consciousness into this picture. If space is information, and brains are information processors, then consciousness is not happening in space in the way we think. Consciousness is a pattern of information interacting with itself. Your experience of space distance, depth, direction is constructed. Your brain receives signals and builds a spatial model. Space, as you experience it, is already an informational simulation. This raises a disturbing but fascinating possibility. The external universe and your internal perception may not be fundamentally different in nature. Both are informational structures operating at different scales. Some researchers believe space-time itself may emerge from quantum entanglement. Entanglement is pure information. When particles are entangled, their states are correlated regardless of distance. Distance becomes irrelevant. Relationship becomes everything. In experiments and theoretical models, when entanglement is reduced, space falls apart. Geometry collapses. Connectivity vanishes. Space ceases to exist. This suggests something profound. Space is not the stage on which physics happens. Space is the result of physics happening. And if that's true, then the universe is not made of matter moving through space. It is made of information organizing itself into stable patterns we call matter, energy, and space. This also reframes the idea of emptiness. There is no nothing. There are only regions of low informational density. What we call vacuum is not absence, it is minimal structure. Now think about the implications. If space is information, then faster than light limitations may not be about speed through space, but about limits on information transfer. Locality itself becomes a rule, not a necessity. If information defines geometry, then changing information could change space. Advanced civilizations might manipulate space-time not by engines, but by rewriting informational relationships. Wormholes, in this view, are not tunnels through space. They are shortcuts in information networks. Two distant regions become directly connected. Distance collapses because relationship changes. This also connects to simulation theory, but not in a simplistic way. The universe does not need to be a simulation inside a computer. It already behaves like one. A self-updating informational system with rules, limits, and error correction. Even physical constants may be informational constraints. Maximum speed. Minimum length. Discrete energy levels. These look suspiciously like bandwidth limits and resolution settings. Now here is the truly unsettling part. If space is information, then information is more fundamental than matter. And if information is fundamental, then meaning may be closer to reality than we think. Information is not just data. It is difference. Structure. Relationship. Order. The universe, at its deepest level, may not be made of stuff but of distinctions. This would mean reality is closer to language than to substance. Closer to logic than to material. It also means that what we call physical is already abstract. Atoms are not tiny solid balls. They are probability distributions, fields, equations, informational tendencies. So when you look at the night sky, you are not looking into a vast empty space filled with objects. You are looking into a structured informational pattern that your mind translates into depth and distance. Space feels real because information is consistent. And consistency creates reality. If one day we discover a deeper layer beneath space-time, something from which information itself emerges, then space will once again be redefined. Just as solidity vanished into atoms, and atoms vanished into fields, space may vanish into code. Not digital code as we know it, but something even more fundamental. The universe may not exist somewhere. It may exist as something. And that something might be information. If this is true, then asking where are we in the universe may be the wrong question. The better question might be, what pattern of information are we? And why does it feel like space? If this idea is even partially correct, then reality is far stranger and far more elegant than we ever imagined. The universe is not silent emptiness. It is a message, a structure, a story written in information. And we are part of the sentence. Thank you for watching, and if you enjoyed this journey into the deepest ideas about reality, don't forget to like the video and subscribe to the channel so you never miss what's coming next on Information World.